Let's go ahead and recreate this symptom. Hey there viewers, welcome back to Supermariodiagnostics once again. Today we are working on a 2013 Volkswagen Jetta. The customer's original concern, as stated by them, is that it just stalled on them. They tried restarting it, it wouldn't restart, and they had to wait until it got cold before it would restart. First things first, we always do a pre-scan here, right? So we are going to take a look at the codes, right? It's only the first step. Taking a look at codes is only the first step. We got a bunch of modules snitching on the engine computer saying no signal or communication. So to be perfectly straightforward with you guys, I have no approval for anything up until this point. I literally just brought this car in, hooked up the scan tool, and started having VIN readout problems. And I'm like, man, what's going on with my tool? And then I went ahead and found all these no communication codes. And I'm like, wait a minute, I just brought this thing in. So I went back into the car, and it was a crank no start. So I decided, let's pick up the camera. Are we done? Right? I didn't get any approval. I looked at the car. I did a vehicle scan. Are we done? We're not done. All we've proven is that we have no comms with the engine computer. But we have not confirmed anything else. There are other things that can happen that can cause lack of comms with the engine computer. Namely, bad grounds, bad power, bad communication signals up to the engine computer. And there's one more. Everyone always forgets this one. That's why I love bringing it up, because everyone always forgets. What is it? The 5-volt reference, right? Now, I call it 5-volt reference, but there's other reference voltages in other brands. But for now, for this vehicle, the 5-volt reference is at play here. It's the most ignored circuit of all time. And I haven't done any testing. It's not like this is going to be a 5-volt reference issue. I'm just saying, it's one of the most overlooked circuits when it comes to no comms with the ECM, and then you put a brand new ECM in there and you still have a no comms and everyone is pissed. So we don't want that here, right? We don't want that to happen to us. So picked up the camera and decided we're gonna check powers, grounds. It sounds easy, right? That's because it is for the most part, but I can't tell you how many shops don't test. It doesn't take all that much time, right? We're gonna do a loaded test on our power circuit. We're gonna do a loaded test on our ground circuit. We're going to scope our CAN bus lines, high and low. And if we have a little bit of theory, we know CAN high and low on the powertrain bus is supposed to be 1.5 to 2.5, 2.5 to 3.5. And we're going to check our 5-volt reference, right? The last thing we want is for a crank sensor to be shorting the 5-volt reference and causing our no comms. And we overlook that, put a new engine computer in this, only to find out that a crank sensor would have fixed it, right? We don't want that. Couple things we could rule out, right? All we did was scan the vehicle. This is the whole point of being a technician, is just gathering data, just eating all that data up and coming out with an answer, right? So what can we already rule out? A powertrain bus issue, because we have other modules in that bus saying, hey, we can't talk to the ECM. So we know that the rest of the bus is good. Do we know it's good up to the ECM? Not yet, right? One of the things that we can deduce is, according to our customer's concern and the way that we're able to recreate it, let's see if we get lucky here. I doubt it, but nothing. Still a crank no start. Customer said it stalled on them and they had to wait for it to cool down. This could be a heat-related issue within the ECM, but we're not going to just because we know that doesn't necessarily mean that everything is great, because a crank sensor can short thanks to heat. I've seen it before where a crank sensor gets hot and actually shorts internally, and then it gets cool again and everything's fine. It's nuts, but it's happened to me before. So one of the points I want to make real quick before we even ask the customer for any approval is that I urge every shop out there to start charging for Diag and stop just subsidizing and eating all of the Diag. Now, if you are one of those shops that just doesn't test, then you shouldn't be charging for testing anyway. So more power to you. But I would urge you to start testing. Last thing you want to do is get burned. This may end up being a video of just going right into the computer, and it's the computer. But I just want to get that out of the way real quick before I proceed. We're going to go ahead and ask the customer for approval. We're going to request approval for electrical integrity testing up to the ECM. It's not like we're pulling a code, charging for diag, and replacing the ECM. We are going to confirm that the ECM has everything it needs in order for it to communicate and operate, but it just fails to do so. Of course, we're going to have to recreate the conditions in which the engine computer does not communicate. This engine's going to have to be hot. Hood might have to be closed for a little while. I might have to let it run, let it stall, and then start my testing. All right, so we got the approval to dig in deeper. We're going to go ahead and confirm everything good, electrical wise, up to the ECM before condemning it as we should. Right, so we're going to look for powers, grounds, comms, and 5-volt reference. So we got all data pulled up according to the VIN number as per usual. And there are several ways we can find this information, but I typically go to the connector view if there is one. And for that, we're going to go straight to the electronic control module. And I don't see a connector view. There, actually, it doesn't say connector view, but there it is. Under location. So sometimes you got to go in and out into different hyperlinks, but there it is. We have a 94 pin connector and a 60 pin connector, and to find out which wires we're concerned with, we're gonna have to go to the powertrain management diagram. It's a 5-page diagram, and I can already see some big old grounds right here on our pins 1 and 2 of our 94 connector, which we can see right here, our bigger connector. And we can see some red and green coming from this fuse over here, but this fuse appears to be controlled by a power supply relay. And that black and gray, we can see that the power side of that coil is given through a hot at all times through fuse 14 right here. It's a 5 amp fuse. And then we can see our ground, our black and gray, is being grounded by the engine computer, more than likely. Yep, engine computer. Still on our T94, as we can see over here. And what I'm expecting to see is, at the very least, that I won't expect that relay to be closed when the ECM is acting up. That's normal. It may just not be there. And that could be an internal fault. That could be the internal fault in the engine computer. But what I'm really more concerned about is the hot at all times, or a switched power, some kind of terminal 15 or accessory or ignition power going to the engine computer provided by another module, just like in BMWs with the CAS module. The CAS module provides terminal 15 and terminal 30 to the DME. And Mercedes does the front SAM. It provides terminal 15 and circuit 87 power to several modules. So you may not see necessarily a relay controlled terminal 15 power directly going into the engine computer. Because look at what we see here. We see all of these fuses that are controlled by this relay, but that's controlled by the ECM. And if the ECM is failing, it's not going to turn on. It may not turn on that relay. So we're looking for a hot at all times or something like that. I see a hot at all times going over here to these two fuses 25 and 14. So fuse 25 leads us to a power supply relay, and if we continue following it, it takes us to a terminal 50 relay. So that looks like it's a starter circuit relay, that fuse 25. Fuse 14 goes to the power supply, the engine electronic engine control module power supply relay. So that's not going to be our hot at all times. So where's it coming from? Is it from the fuse panel? Is it from another module? We're gonna have to keep digging, right? So, and the only other hot at all times we can see here is going to the secondary air injection pump, which goes to fuse 21 directly to the secondary air injection pump. Now, something does stand out to me. It's this right here. Vehicle electrical system control module. A little bit of product knowledge. A lot of Volkswagens, this is the immobilizer. So, but I'm not so sure on this one. This one might be the cluster, but I do see a black and red wire coming from that vehicle electrical system control module to the pin 19 of our T94 connector. So our black and red right here, pin 19, is coming from the vehicle electrical system control module. So I would imagine that when we turn on the key, that vehicle electrical system control module says, all right, we're going to give power to the engine computer to turn it on, to wake it up. So, and then if everything goes well internally on the ECM, it supplies the ground necessary to close this relay, the power supply relay. So that's my train of thought. We're going to have to keep an eye on the black and red. Is going to be crucial, I think, to this process. And I am expecting to see, I'm going to keep an eye on one of these red and greens. These are redundant wires, but I'm going to keep an eye on one of them to see if that relay closes during failure. I expect it to. I don't think that that's going to be the cause of our failure. That's just going to be another symptom of our failure. And finally, the bus lines, right? When we went over here, I saw something. We went to our black and grays, pin 69. We can see our computer data line system. So orange and black, orange and brown. According to the CAN bus protocol, this should be a twisted pair, as I've stated in many videos. It's 1.5 to 2.5 on one line, 2.5 to 3.5 on the other line. That should be the signal that we are getting. If signals drop out or if they become corrupted, we will see that during testing. We're going to scope these lines, make sure that everything is good there. Now, most of you are going to say this is overkill, but you know what? I am a believer in just testing once and being done with it. So I'm going to explain this. It's really not as bad as it looks. It truly isn't. We got 3 channels going to our scope. We got one of the CAN lines, and the 5-volt reference coming from our cam sensor, which I haven't even turned on the vehicle yet. It's the first thing in the morning. And I may be on the signal wire. I'm going to check it once the vehicle's running and it's good to go. This right here is going to be our brown wire and our red and green. That's basically checking the Motronic relay. That's going to light up. When it fails, I expect that not to light up anymore, but we're going to be checking our ground while we're at it. On this wire right here, we've got it going to this test light. It's an incandescent test light. It's not an LED test light. There is a bit of a load on it. That is our wire that is going that is coming from our vehicle electronics system control unit. I forgot the name. It could be our immobilizer. That's supposed to be hot at all times. Not really hot at all times because obviously it's not hot now. It's basically a terminal 15. If I turn on the key, it should light up. Like I said, I haven't even started it. All I did was put my testing equipment in, and we're gonna do a key on. And it doesn't even turn on yet. Let me make sure that my connection is good. I believe it is. I'm gonna try running the vehicle. Maybe that's how it works. Guess we're doing this all in one shot. Usually if these are DSG transmissions, they require the brake to be pressed. And I'm gonna have to recheck my connections on this one. I'm gonna set this up. So obviously my third channel is a cam signal. What I want is the 5-volt reference. And there it is. And we've got our CAN lines here. Which I don't need to really zoom in much for this, but basically all we need to do is keep an eye on it so that when it stalls out, see if anything drops. That's really it. As for this, I'm gonna check this off camera because it's not easy to do everything on with one hand. So we got our light on. That's our relay. Our ground is obviously good. We're gonna let this warm up, get it to act up, and I'll keep the camera running up until then and catch it in the act. Wow, so I was setting up my camera and I didn't even get to finish. I was setting up the monopod, and it stalled. It didn't take long at all. So much for my testing there. I'm gonna stop the scope. You can actually see where it died. So that rules out a 5 volt reference issue. We got it where it's running right here, and then it just dies. So if we zoom in, we can see our CAN bus looks pretty good. Our voltages are all the same. It's all present. And so much for catching it in the act. I really wanted to do that for you guys, but I guess I didn't get it fast enough. Now, the funny thing is that our light is still on. That Motronic relay is still on. So we've ruled out power and ground. We know the engine computer's still closing that relay. We have no, I wish I would have gotten this in time. Just, like I always say, you want everything to go wrong, just pick up a camera and start filming what you're doing. Because that's literally how it works. So I'm gonna recreate the symptom. Sorry for the shaky cam. And see if this thing starts, because that is too funny. And there you go. Now again, remember, we're dealing with a communication issue. I'm not concerned with a camera crank signal. I don't think this is a crank signal issue. We had no comms with the computer. We didn't have a crank signal, P0335. We didn't have that. So I don't think that that's what's going on here. What's going on is the engine computer's lacking communication, and it's internal to the engine computer. I can't tell you what it is right now. All I can tell you is that everything is present for it to work. If this thing did not have this wire that I was supposed to be testing with this test light, which comes from the vehicle electronics module, who knows, that could be a wake-up signal. But if that was a problem, this would not be on. So we're using a little bit of logic, a little bit of deduction, and I can confidently call this ECM bad, sell it to the customer. I don't really need to sell it. It sells itself. It's wrong. It's bad. It's messed up. It's not working. And have no doubt whatsoever that a new ECM will fix this vehicle. So I'm gonna write it up and present our findings and take it from there. So we finally got the approval to replace the ECM. They're gonna go ahead and put a used unit in there, which the factory software tends to be very lenient with. They usually has no problem doing that. It is the customer's choice. They went with a used one. That's okay. I don't really mind it. But you know, obviously we're not, you know, responsible for the problems that are inherent to used modules. Half the time they're used for a reason, and usually they're bad. But 50-50 chance, there's a 50-50 chance it's good, and it may work, it may not. In the end of the day, that's what the customer decided to do. Don't get mad at us. You know, for the public watching this, if you go to a shop and you want to use used parts, don't get mad at us if it doesn't work. That's not our fault. We offered you a new part, you decided to go with used, and this is the outcome. So we're gonna go ahead and use Otis to do this. Otis is pretty lenient with used modules. That's usually not an issue. I'm not gonna film the programming part. That's gonna be for Scanner Diner Premium. Those of you who haven't heard, Scanner Diner has a premium channel. Pretty sure you've heard this, but I do contribute to that, and I want to kind of even it out between the two. So I put Diag on YouTube and the programming stuff more on Scanner Diner, and that way there's a little bit of everything for everybody, right? So that's what we're gonna do. I will show the afterwards. We're gonna leave it running. I'll probably do a time lapse with a clock behind it. This thing will just die in like 5 minutes, not even 5 minutes. Last time it didn't take any time. I don't think it'll die just by leaving the ignition on. It has to be running, I believe. But for programming, we're gonna need the ignition on. And we're gonna see if that happens, but I doubt it. We're gonna go ahead and program this sucker in and get back to you guys, show you the final results, and call this one a fix. So we've got the original computer here. We got the used one programmed in using Otis. If you guys are interested in finding out how to program it and see all the issues I ran into, which really was just one main issue, but the real world programming, be sure to check out Scanner Danner Premium for that. That being said, I'm gonna go ahead and run this thing and leave it idling for a good while and make sure that it does not fail. So the time is 2:03. We're gonna leave it running for a while. It's actually 3:02 in the real world, but it says 2:03. We're gonna stick with the 2:03. We're gonna come back and see how it does in a little bit. So with the original ECM, it would have stalled by now. The problem is that, as we saw in the Scanner Danner video, there's a radiator fan control module issue, code at least, and that was not there with the original module. So I think we found out why this just became a used module. Of course, we do not assume liability with used modules. It's just the nature of the beast. Be warned. You want to go with used parts, you're probably going to inherit the problems that made it become a used part. So I think that concludes this video. This is a confirmed fix. We're going to see what the customer wants to do, if they want to go with another used one or a new one. That's really up to them. Either way, it's fine with me. Doesn't make a difference to me. We don't need to upsell anything. They just need to make a choice. Do they want to gamble, or do they want a one and done fix? So that being said, thank you all for taking the time to watch. I hope you guys found this useful. And again, go check out Scanner Danner, see the mission I went through with this one. And I'll catch you on the next one. Take care. So on a final note, that radiator voltage code, that voltage supply doesn't come from the ECM. It's actually a separate fuse, which was blown. All the remarks that I said about getting a bad ECM, that still applies, but, and I'm not going to delete it from the video, but obviously I was wrong in that case. I was speaking preemptively without doing any research, looking at the diagrams. But after I filmed everything, I went back to the vehicle, put the original ECM back on, and saw the code there. And then that's where, I mean, obviously I didn't try to adapt it. It had the immobilizer message on the dash. I saw the code there and I was like, okay, well, I guess it's not the ECM. Looked at the diagrams, saw the fuse location, and found the fuse blown. The fans do not turn off, and they're going to have to be replaced. Even though there's no command going to it, I've already confirmed that off camera. But just wanted to put that out there. The message still applies concerning used modules, so I'm going to go ahead and leave that in there. That's it for that side note.